So now we are going to look at the Graham's law of diffusion. So the statement here is that the Graham's law of diffusion actually stated that under constant temperature and pressure, so the rate of diffusion of gases is inversely proportional to the square root of their densities. So the rate of diffusion is represented as R. Let's use R as a rate of diffusion. So it's inversely proportional. It's inversely proportional to the square root of their density. So we use rho as a density. So the rate of diffusion of gases is inversely proportional to the square root of their density. And of course, ladies and gentlemen, you should remember whenever we have proportionality, then we replace it with constant. So therefore, now our rate of diffusion is going to be R. R is equal to K, which is constant, all over square root of the density. And of course, from here we can easily make K subject of the formula, or we can have something like R1 all over R2 is equal to R2 is equal to square root of rho 2 all over rho 1. So because we have proportionality, so whenever we have proportionality, you can actually take it as different values. You can actually have R1 and R2. You can also have rho 2 and rho 1. This one is not R, it's rho. So we can have rho 2 and rho 1. So now from here, we can clearly see that this is the mathematical relationship. So in this case, actually, the rate of diffusion is represented with small letter r, and of course, the density of gases is represented with small letter d, where R1 and R2 will be the rate of diffusion of two gases if densities D1 and D2 respectively. So it means that if you have two gases, you can actually have different rate of diffusion for gas 1 and gas 2, and of course the density of gas of the two different gases will also be represented. So therefore now from here we can now clearly see that from our previous derivation we can now say the rate of diffusion of gas 1 all over the rate of diffusion of gas 2 is equal to the square root of density 2 divided by the square root of density 1. So I think since here they use small letter d, let's use small letter d instead of the rho. So to do that, we are now going to use be using the small letter. We are now going to use the small letter d. So therefore now we have now going to use small letter d2 as density 2 and d1 and as a density 1. So this is the formula for calculating rate of diffusion. Although there are different derivations, we are going to derive so many formula from here. So let's look at our next slides. So you see now, according to the Graham's law of diffusion, we have R1 is equal to K all over square root of 1 all over D1. Then we have R2 is equal to square root of, we have R2 is equal to K all over times square root of 1 all over D2. So therefore, at the end, we are going to have this. So by combining both equation 2 and 3, we are going to have the rate of diffusion of gas 1 divided by the rate of diffusion of gas 2 is equal to square root of the rate of diffusion of, is equal to the square root of density 2 divided by the square root of density 1. So therefore, at the end, remember, there is a relationship, there is a formula that actually gives us a relationship between molecular weight and vapor density. And of course, molecular weight is equal to 2 times vapor density. So it means that density is equal to molecular weight all over 2. So therefore, we are going to represent, or we are going to actually substitute our density with M2 over 2, and of course M1 all over 2. So at the end, our rate of diffusion is going to be R1 is all over R2. That is something like this. We're going to have R1 all over R2 is equal to square root of M2 all over M1. So this is going to be also another formula for calculating our rate of diffusion. So again, the rate of diffusion can also be defined as a volume of gas diffused per unit time. So the rate of diffusion can be volume of gas diffused divided by the time of diffusion. So we can have this. So at the end, let T1 and T2 be the time taken to diffuse the volume in mil of two different gases. Then at the end, we are going to have something like, so at the end, we are going to have a formula like this. R1 all over R2 is equal to T1 all over T2. So therefore, ladies and gentlemen, I think it is very, very important from here you understand that we have the formula for calculating rate of diffusions. We have three of them. This is one, and we have another one which says R1 all over R2 is equal to square root of D2 all over square root of D1. And then the last one is the one that says R1 all over R2 is equal to square root of M2 all over M1. So these are the three formulas that we are going to use for calculating rate of diffusion. Okay? So the next thing is actually importance of rate of diffusion. And ladies and gentlemen, we are going to stop here, and I'm going to share with you this video on YouTube and watch, and then also we are going to look at some questions and solve like we did in that of the Dalton's law of diffusion. Is that clear?
Yes, sir.